Hello, welcome to the video. If we saw the question number of the 2025 exam, and the question says that transverse electric field of electromagnetic wave is expressed as this is the transverse electric field. It is given as E is equal to sigma cos A dot R minus omega T and bracket X step plus alpha. These are vector quantities, so it's vector sign where A vector is given as x minus y plus z. This is the propagation vector. This is the electric field vector. Alpha is a constant, and all quantities are in SI units. We are told to find the amplitude of magnetic field. What is the amplitude of magnetic field? That is equal to the magnitude of magnetic field. We know by concept that electric field, propagation vector, and magnetic field are usually perpendicular to each other. First of all, we have to find this vector. What is this electric field vector? So we see what I did here. As we went on the diagrams, it looks like this. This is perpendicular to each other. Similarly, now we have to find the thing. What is the okay? For this, we have to first find this E. What is E? Because E and K that must be perpendicular. So first of all, E dot cross product of E and K must be equal to 0. From this, we can get the value of alpha. What is the value of alpha? We can find out. Second, we also know that A is equal to 3 by C. By this, we will able to calculate the magnetic field. Now, first of all, let's find out the alpha. What is alpha? For finding out alpha, what is electric field vector? Now, if I decompose this equation into parts, it will come out at E naught into 2x cap plus alpha y cap. This is the electric field vector, this one, and multiply the cos A dot R minus omega t. This is the oscillatory part. That means what is oscillating? This part is the oscillating part. Second part is the oscillating part. This means this up and down or this sine wave type function or cos wave type function is coming out by this part. Here it is cos. Therefore, this is not the right wave. The right wave must be like this. It just determines how the wave is moving. At x is equal to 0, how is the wave? That is justified by the oscillating. Yes, this part, this first. It determines this vector. In which direction is this electric vector? If I consider the x, y, z coordinates, x coordinate, y coordinate, and z coordinate, in which direction there is E vector, in which direction there is A vector, and in which direction there is B vector. These all directions are given by this. Okay. So basically, this is the direction vector of this vector. It is provided as E naught into x plus alpha f. This is the electric wave, and E naught is the magnitude. Okay. So now, next thing is that here it is correct. Now, next thing is that we know that E dot T is equal to 0. That means this vector and this vector dot product must be equal to 0. That means E naught E naught 2 I x cap plus alpha y cap dot 3 x cap minus 2 y cap plus z cap. This will be equal to 0. When we do the dot product, it comes out as E naught in the bracket xx6 plus minus 2 into alpha, that is minus 2 alpha, plus 0 into z, that is 0, is equal to 0. From this, we can get the value of alpha as 3. We have now find out the value of alpha. Value of alpha is 3. Now, just we have to find the magnetic field. Okay. So, for the magnetic field, E is equal to, sorry, E is equal to magnetic field is equal to E by C. We know that from that, we have to calculate the magnitude of E. For calculating magnitude of E, we know that C is a constant and E, amplitude of E or the E vector. This is a vector, this is a vector, and this is also a vector. So, first of all, the B vector will be E naught by C 2x square plus what is alpha? 2x square plus alpha is 3 by 10. This is the value of B. Now, on solving this formula, it comes out as E naught by C into 2x square plus 3 by 10. Now we need the magnitude. For calculating the magnitude, we will just take its square root and E naught by C square in the bracket 2 square plus 3 square. Okay. So on solving this, we will get B is equal to E naught by C. That is, this is square root and this is square root. It cancels out. We are left with E naught by C multiplied by 2 plus 4 plus 3 is 9. 9 plus 4 that is equal to 15 E naught by C. This is the final magnetic field. It's the magnitude of magnetic field. That means this uh, magnetic field vector it can have the topmost point of this oscillatory loop. This can be either 13 E naught by C or minus 13 E naught by C for this one. So it represents. So our option is option number A. Let's do the solution.